Alright, so in this video we're going to go over some physics proofs for kinematic equations. I think the first one we're going to try and prove is the final velocity minus initial velocity, or final velocity squared minus initial velocity squared equals 2 times the acceleration times the change in position, delta t, or delta x. So I'm going to try and prove that one. And so to do that, we're going to start over here. We're going to say that the change in velocity can be kind of described. If I can zoom in. Nope. Yes, there we go. If I can zoom in, it can be described by the final minus velocity initial, or it can be described by, if you have constant acceleration, you can take acceleration and you multiply it by time. Right? So if you have meters per second times seconds, one of the seconds will cancel out. You just have meters per second. So that dimensional analysis kind of works out. So now we have this. So I'm going to go ahead and move this over here like that. And we have the velocity final equals velocity initial plus acceleration times time. And I'm going to square both sides. Again, we're trying to get to the final velocity squared. And this means we have final velocity squared equals initial velocity squared plus 2at initial velocity plus at squared. So that is FOILed. The next thing I want to do is we can move your final velocity squared back over to the initial velocity side, or vice versa. Move the initial velocity over to the left side, the side with the final velocity. Okay, and that leaves us with this, and we're going to actually factor out an I'm going to factor out a 2a, and you'll see why in a second. So factor out 2a, that leaves us with t times initial velocity plus 1/2, because 2 times 1/2 is 1, which would leave the coefficient out of there, times the acceleration times the time squared. And actually in here, we're actually going to factor out another t. That's the same thing as 2a times, I didn't factor out 2at for a reason, so we're going to put that t here, initial velocity plus 1/2 at. And this might look familiar to some of you, and if not, if it doesn't look familiar, that is perfectly fine. Let's see if I can move. I'm trying moving this over. Perfect. Okay, I'm going to move this over. I'm going to do this work in blue. All right, so we have our other equation that we memorize. I'll do another video about this one in the future, which is just final position. Final position equals initial position plus the initial velocity times time plus 1/2 the acceleration times time squared. We can move that x over, so we get final minus initial, that's change in position. And then we're left with this. We're going to factor out the t there and a t there, so we can say t times initial velocity. Some of you might now know what I'm doing. I assure you this is the plan all along. Times t. We can just quickly check. T times vt is that. 1/2 a times t squared, that checks, and that is change in position. Okay, now we're going to move back down, go back to green. So now what we have is this is exactly that. So we can replace this for delta x. So that leaves us with, drum roll please, the final velocity final squared minus velocity initial squared equals 2a delta x. And that should blow your mind. Yeah, so there is the physics proof for the final velocity minus initial velocity using acceleration and displacement, using the final position equation we know over here. All right, sweet. Thanks, guys.